Hi, everyone. Welcome to this talk. Thank you for coming. I'll be talking a little bit about Cloud Native Data Commons, lessons from building the Earth Engine Community Catalog. For those of you who are here, I know that you have had a lot of conversations about data formats. You've learned about Zarrs and COGs and Kerchunk and flat GeoBuff and whatnot, right? This talk is not going to focus on that at all. It's going to focus on it from the consumer point of view. It's going to focus it from the people who are producing the data, but also the people who are actually consuming these data sets across different domains. And that's the hope from this. Here's some information about me. You can scan that QR code to find me on LinkedIn. But I run my own company. I'm a data consultant for that. I am also a research associate and senior geospatial engineer at Desert Research Institute. And there's a bunch of other things, but I'm also a Google developer expert for Google Earth Engine, and I'm be talking about this talk about related to Google Earth Engine, which is the Earth Engine Community Catalog. Now, let me paint a story here. Let me start by going back a few years, and I'm going to go to a slide or a presentation that we gave in 2023. This is a conference that happens that Google runs every year. I'm not advertising for it. Actually, the dates closed just yesterday, so if you didn't apply for it, too bad. But it's a conference that happens called Geo for Good, and people come from around the world with different ideas. They want to learn about not just about Earth Engine, but about what's happening in the geospatial world. They share ideas. They share what is needed to do an analysis end-to-end in a cloud environment like Google Earth Engine. And don't worry, I'm going to give an introduction to Google Earth Engine as well. The reason I start with this slide is because the primary focus for the community catalog started with a bunch of scientists who were requesting data and who didn't have that in Google Earth Engine. And the talk that we gave was about how do you publish impactful research using Google Earth Engine, and we realized that, like a lot of you might have found, that people are producing very impactful data products, but it's not really in a format or in a place where you can just plug and play. You have probably found those zip files somewhere, or you have tried to download them only to realize that they're netcdf and there's some conversion that you needed to do, unless you actually like netcdf, and that's okay too. And the fact that these are scientists who don't necessarily have an incentive either. You have to imagine that the mindset of this is there is a fixed amount of money. You have to publish good science. You have to get the paper out. You have to get the products, and I'm saying products because these are derivatives. This could be like land cover data sets. This could be hydrology, land, like any kind of like river width data set, for example, and things like that. So that was the primary focus on how the community catalog was born. So going back a step, right, I said I'll define what Earth Engine is. Earth Engine is a cloud-native analysis engine. So I like to lovingly call it you can do remote sensing in a browser. When it started, it was probably one of the first ones to exist. Of course, there was a lot more that followed. There was always Pangeo and some others that were there in the open source community as well, so I don't want to exclude those. But it was the first one. There was a massive push for global scale analysis. And in 2013, Hansen wrote a paper about we are going to study all of the global forests. I'm not going to go into what is a forest, but he wrote a paper that basically analyzed about 30 years of Landsat data, something that would have taken someone at a research institute like probably 100 years or more. So, Earth Engine maintains a catalog. It maintains a catalog of about 90 petabytes of public data. But one of the questions that came out of this was, what about the data sets that the people are producing or people need, which Google doesn't necessarily think of as important? So the idea of community catalog came because there was a single query that was generated by a student that was studying population data. And if you all remember, someone, I think, showcased the HRSL, which is the high resolution settlement layer from Facebook or from Meta, right? That data set did not exist in Earth Engine. And a student wrote in a forum and said, like, hey, can we make this data available in Earth Engine? And rather than relying on the Earth Engine team, I was like, okay, what if we just ingest it? There is no need for us to wait for Google. Google was giving us a 250 gigabytes of storage. What if I just bring that in? So it's all started with that narrative, and the Earth Engine Community Catalog was born as a result of that, which was, what if the community could tell us which are the important data sets rather than a top-down approach where a company gets to decide what are the important data sets? What if there was a bottom-up approach where the community says, okay, I feel like this data set, which is about like solar reflectance in this area or about urban heat island effect in this area, is going to be the important one. So I started with just that one data set, like I said. I'm pulling in stats from last November. I didn't have time to run this. But you can actually go to the main page, and there's a daily updated stats, so you can find the stats there as well. But as of November 2024, we have about 0.5 petabyte of data. We have 510 terabytes actually right now. And we have billions of features and millions of images and features and feature collections and so on. Just to give an idea of who actually utilizes the community catalog, the community catalog is accessed from 1,960 global regions, all countries in the world, 13,200 cities and towns based on the last statistics. It gets about 1.5 million requests per month in terms of the number of people who are actually visiting the page. So now I'm just going to jump into a live demo because I feel I enjoy live demos better than slides anyways. Okay, if people wanted to go to this community catalog, they can scan that. I'm just going to jump ahead, but if anyone wants to scan it, or you can just Google it, and you should be able to land here. Okay, so as I was saying, the community catalog was designed around the idea that if the community could produce these data sets, they didn't have a nice place to store it. Most of the data set was fragmented. They were stored in Zenodos and Dryad and Figshare and all of those places. But for you to be able to truly plug and play, there wasn't really a mechanism to do so. And one of the core fundamental things that I think we're forgetting is that access does not equal accessibility. I understand that a lot of us are promoting this idea that, okay, we're going to make all of this data into this massive Zarr and people will magically be able to access it. But you have to think about, does the person have the compute? Do they have the throughput to do this? Do they have the internet connection, a stable connection to actually work on this? Is their computers powerful enough to churn the numbers or do whatever, whether it's locally or in cloud? And do they have a credit card to actually buy a cloud account to do any of this analysis? So there's access, and then we're talking about accessibility. So when I started this project, the Earth Engine platform, which was free for researchers, was a great fit because you get the analysis for free. Google pays, it's like batteries included. That was the whole pitch in terms of like why I chose this as a platform to go with, because if you keep the data right next to the analysis engine, and if both of those things are free, it kind of levels the playing field for a lot of people. If you go into the community catalog right now, you can browse it and look for different data sets. Most importantly, people will come here. You can go to the Getting Started and other sections if you wanted to. But more importantly, people will come here, and you can see that we have an array of data sets arranged across different thematic groups. So you have like soil carbon data, you have regional land use land cover data, you have high resolution land cover data. We have Urban Watch 1 meter land cover data, for example. We have analysis ready data. We have the open aerial map subset. So I know that someone presented about open aerial maps. We have about 8,000 open aerial drone imagery that's ingested into the Earth Engine Community Catalog. We have about 100,000 historical USGS topo maps ingested into and it ranges all the way from 1900s to 2014, I believe. So imagine being able to go back in time and do those kinds of analysis. And the reason it becomes powerful is because whoever is producing this data set, right? So for example, this is like a fused data set which works on, like we're looking at leaf area index. You come to any of the pages, what you will notice is that there is a description, we talk about the data set's access, but more and more importantly, we talk about citation, we talk about attribution. Scientists are also looking for a way to get their data discovered. One of the biggest problems right now is there's overabundance of data, and these products are not being visualized or utilized by most people. So what if you could also add their citation? And then you can have an entire snippet of code. But more importantly, what I meant by plug and play is you can go to any of the example codes, and as long as you have an Earth Engine account, it'll load the code for you, and you can just hit run, and the analysis will actually work. It's a pretty massive thing for people with limited resources, but it's also important and useful for a lot of people who just want to utilize the data and look at the data. It's a powerful narrative tool, right? On top of that, people were also creating apps. So I created some apps, for example, and this one was, there's a landscape one. Let me just show that one. Here's the land cover one. There's an annual NLCD data set. The USGS released the annual NLCD, I believe, for the last 20-something or 30-something years, all the way going back to, and I know NLCD, you're like, wait, NLCD was 5 years, right? Every 5 years? No, they released an annual product that just got released, and we can basically look at all of these years and have an app. And the nice thing about this app is this does not require an Earth Engine account. I can go into an incognito window, and this app should basically just load similar to how I was loading it in my window. It's powerful because imagine being able to attach something like this on top of your paper where you can say that, hey, my data lives here. You can plug and play with this data. You can actually analyze the data. You can also like basically build these apps and attach it to your papers as well. So it becomes really, really powerful. So this is what the community catalog is designed to do. There's a lot of interesting data sets here. So I recommend that you check it out if you wanted to have some, like you can look at the global utilities data set. There is night lights data. People are talking about surface temperature, sea surface temperature. There's entire sections on oceans and sea data. You know, like, so if you wanted to look at that, I even have like things like the Ookla 5G connectivity maps. If you wanted to look at speed test maps, those are also there. It's a plethora of data that's been collected and contributed by people. And the way in which this comes is we have a GitHub repo. Someone wants to contribute a data, and you'll see a lot of open issues here. They will come in and say, like, hey, I really want to contribute this GPP data, and they will fill out a form, and they will add all of these details. They'll tell me what the data variables are, all of this additional information. They'll give us a link to the paper, and then I will go and process the data set, clean it up, make sure that it's ingested into Google Earth Engine, and make it available for the whole world to use. It's also very apt that I'm giving this presentation today because I'm happy to announce that I published this a few minutes ago. We are celebrating 5 years of this project being alive. And that means a lot in terms of the fact that it started with like the first data set was about 200 megabytes, and we are at half a petabyte. So you can imagine why this is exciting. And I've tried to highlight some of the pieces that goes into it. Like the analysis engine, like where I go and clean the data, where I analyze these terabytes of data is funded by NSF, for example. I actually go and work with them on producing things like this. So this is by the way, this is the URL for the blog I wrote about the topographical maps if you wanted to check it out. And you can do some powerful things, like you can go into one of these codes, and I have the USGS historical topo, and you will notice that, and I'm just going to zoom in a little bit so people can see. I just have a single line of code, and all I'm asking it to do is say that I have this image collection. If I run an aggregation over the years, can you tell me how many topographical images are available in which year? And it's able to do that really, really quickly, and I'm able to basically showcase that, hey, we have a lot of images from 1948 or 1950 and 51. You also have some overture data in here if people wanted to play with the overture data or the Microsoft building footprint data. And if you want to compare it with Google building footprint data, that's also available here, so if you wanted to do that. This, I believe, is a way for people to not only showcase their work, but to truly meaningfully build a data commons that is built ground up. Because the users are the one who are telling me which data set is important to them. I am not an expert on global fungi, but there's a global fungi database in here. I have no idea about anything about global fungi. But it's fun to work with these people. It's fun to work with these organizations. And I often get to work with people from around the world, people like the FAO. I get to work with the USDA and USGS, and I get to highlight their data sets over a period of time. We didn't leave, because this talk would be incomplete without AI, right? We didn't leave out AI. It's important to add features, not just data, to a platform. As you can imagine, this is a website that has been updating for a period of time. So last but not least, I'm going to show this, that there is also a way for you to ask questions using natural language query. Like, for example, I can say, can you give me a table of all land cover data sets and their resolutions? So what it's doing right now, it has access to the catalog, and you can choose, by the way, this can ask questions to all of the data sets. So I can ask it questions about community catalog as well as the Earth Engine main catalog. But you can also say, for example, tell me about neon data sets, for example. And it'll basically pull all of this information and what collections are available. It's really useful for people to do these kinds of summaries because, like I said, 4,000 data sets. It's going to get even more and more complicated for people to do keyword searches on doing those. So it might be useful. And you can do things like where you can say, like, I would like to study LA fires. And it'll pull out, yeah, I can help you with studying LA fires. It'll tell you which are the data sets that are out there. This is a RAG. It's a retrieval augmented generation, which means it has links to the data sets that it's telling you about. So it's not just like, oh, I'm just going to verbally tell you, now you go find out which that page is. You can actually click on this and go to that data set and see what's available out there. And I can ask a follow-up. For example, I said, why not include urban sky, for example, or did a 10 centimeter resolution capture over that area. I said, why not include urban sky? And if you ask it that question, hopefully it's going to say, urban sky also provides the data, and you can look at the LA fires data from here, and it'll link you to the new catalog. There's a bunch of other features, but I can go on, but I feel like I've already exceeded my time, so I'm going to stop here. I really feel like if people wanted to join this, as a project, as a hobby project, or as something that you have time to contribute to, I would love contributions. Like I said, right now it's a maintainer and team of one. This is very hard to do, but it would be interesting to have more. I have ideas. I have a lot of people I have discussions with, but it would be very nice to have some people who are like, we can help you code some stuff. So thank you very much. Any questions, thoughts? Yes.
Hello, Sam. Thank you very much.
Hey, Jeff.
In your abstract, you mentioned that democratization requires cost absorption.
I did.
So are you absorbing all the cost?
Yeah.
Do you have any thoughts on that?
No, I'm not. That's a great question. And I mentioned that categorically because a lot of people, when they talk about open data, they forget the fact that someone somewhere is absorbing the cost, right? Even if it's Amazon Open Data Program, Amazon is consuming that cost for the rest of the world. In this case, Google is consuming the cost for the community catalog. I have my cost of when I move the data at some points between the NSF compute infrastructure to Google Cloud, but that's the bare minimum cost that I have. But yeah, cost absorption is real. I mean, there is no, I would say, I wouldn't go as far as there's no free lunches or whatever the saying is, but it is somewhat convoluted because it's often hidden with generous contributions by different companies that will say okay, we're going to give you a bucket and you can dump a bunch of data there. The idea for us is that we get to choose. We have absolute freedom in choosing which data sets we get to highlight. It's not Google who is telling us to highlight a specific data. Go ahead.
Super quick, and congrats, this is an incredible resource. Can you get statistics or insights on usage of data of how many people are pulling which data set? So
right now, all I can tell you is how many people are visiting each page of the site, but I've been in conversations with Simon. There is an internal way at Google to pull those numbers for each collections. So the idea is we're working on a paper right now that encapsulates the last 5 years of this work. So hopefully when we publish the paper, we're going to publish those stats as well. Yep. Is it this one?